Jane's utility function is x plus 2y, where x is the consumption of good x and y is consumption of good y. Her income is 2, price of good y is 2. Okay, price of good y is 2, utility equals to x plus 2y, income equals to 2, py equals to 2. Cost of x depends on how many. The total cost of x units of x is the square root of x. So px, okay, total cost for x units of x. Okay, so cost for x units of x. So px into x, this is the cost of x units of x. This is equals to root x. This implies price for good x equals to root x upon x, which is equals to 1 by root x. Okay. So price of good x is changing. Now you do not have linear, basically you don't have linear budget line anymore. Your budget line is going to be a curve. So what does the budget line look like? Budget line looks like pxx plus py is equals to I, which implies pxx is root x plus pyy is 2y is equals to I is 2. So this is the equation of the budget line. Okay. So this equation is also going to be convex. When x is 0, y is 1, and when y is 0, x is equals to 4. So this will be your budget curve. Let's not call it a line, let's call this a budget curve. Okay. Now utility is x plus 2y. Okay. Now utilities are x plus 2y. So again, utility function would, so the maximum utility function x plus 2y, it would either be like this or it could be steeper. So when it is flatter like this, the highest utility will happen here, and when it is steeper, this is the purple one is the flatter one, and when it is purple one is the steeper one. When it is flatter like this, completely below, then the maximum utility will happen here. Can there be a tangency condition? No, there won't. It has to be really steep, so it feels like mostly it's going to be this point. Basically there won't be a tangency condition. Tangency cannot be the optima. Why tangency can't be an optima? Let's look at why tangency condition cannot be an optima. So I'm saying that there exists some, so remember that this is the budget constraint and this is some tangent indifference curve. So indifference curves are straight line. So I'm saying if you have a tangency condition like this, where the indifference curve is below and the budget constraint is above, so in this situation you can definitely construct a higher indifference curve which will be intersecting the budget constraint. The aim is to not reach the highest budget constraint, the aim is to reach the highest indifference curve, right? So highest indifference curve will be higher than this tangency point. So tangency point can never be the reality. The reality would either be this point or this point. So no tangency point can be the optima. So just check the utility at the two optimas. So the two corner points. This corner point was 0 comma 1 and this corner point was 4 comma 0. So let's check the utility at these 2 points. So at utility at 0 comma 1 will be equal to, utility function is x plus 2y. So utility at 0 comma 1 will be 2, utility at 4 comma 0 will be equal to 4. So utility is higher at 4 comma 0, so she will consume only good X. So maximum is spending all her income on good X. So the answer is C.